Welcome to part 2 of Java Basics Roadmap. In part 1, we covered data types, strings, and collections. Now we move into Java OOP, classes, objects, access modifiers, constructors, this and super, static, interfaces, abstract classes, overloading, and overriding. Here's the roadmap. We start with the classes and objects, because everything in OOP builds on that. Then we cover access modifiers, constructors, this and super, static, interfaces, abstract classes, and the difference between overloading and overriding. First, classes and objects. A class is the blueprint. An object is the real thing created from that blueprint. A class is a blueprint. It describes what data an object has and what actions it can do. In this example, student class has name and age, and it has a study method. An object is an instance of a class. S1 and S2 both come from class student, but they can store different names, same blueprint, different real objects. Fields store state. Methods define behavior. In a bank account, balance is state and deposit is a behavior that changes the state. OOP mental model is not only about storing data. Ask what responsibility this object has. A good class should define a clear job and methods that belong to that job. Next, access modifiers. They control visibility. In other words, who's allowed to access a class, field, or a method. Java has 4 common access levels. Public means everywhere. Private means only inside the same class. Protected means same package and subclasses. Default means package only. Private is your safest default for fields. It prevents other classes from changing your internal data directly. Instead, you expose controlled methods like the method deposit. Public means other code can access it. Use public for the real API of your class, not for every field and method. Public should be intentional. Protected is useful with inheritance because subclasses can access it. Default or package private means only code in the same package can use it. This table is the practical map. Private is the most restricted. Public is the widest. In real projects, start private and open only what other code really needs. Now, constructors. Constructors are special code that runs when you create an object. Their job is to initialize the object correctly. A constructor has the same name as the class and has no return type, not even void. It runs when you create an object with no. When you write no student with Omar, Java calls the matching constructor automatically. After that, the object starts with name set to Omar. If you write no constructor, Java gives you an empty default constructor. But once you write your own constructor, Java stops creating the default one. Constructors can be overloaded. That means same constructor name but different parameters. This gives you multiple ways to create the object. Now, this versus super. These two keywords are small, but they appear everywhere in OOP code. This refers to the current object. In a constructor, this point name means the field of the object, while name without this means the parameter. This with parentheses calls another constructor in the same class, but it must be the first line. This helps avoid repeating initialization logic. In fact, you won't see this much. Super refers to the parent class. When you inherit a class with extents and want to change some of the code in the inherited methods, like the method makeSound here, then you must call the parent method first, using super point the name of the method, like in our example, super point makeSound. And then you can write more code. As a result, you will have the code from the parent method and the code you added. Here again, if you want to inherit a class with extents and you want to have the same constructor like in the parents class, then super with parentheses calls the constructor of the parent class. It must also be the first line in the child constructor, like in our example. Next, static versus non-static. This is about ownership. Does something belong to the class or to each object? Non-static fields or attributes belong to individual objects. If one student is Omar and another is Maya, each object has its own name. Static belongs to the class, not to a specific object. There is one shared copy. A school name shared by all students can be static. Static methods are very common. You'll see them a lot. Why do we use them? Static methods are used when we want to call a method very common and a lot in a package, which means in other class. So if you want to call a method in other classes, you need this method to be static, which means you call it in other classes in the package without initializing an object of the class of this method. Type down in the comments an example of a static method. A common mistake is trying to use non-static fields or attributes inside a static method. So if you want to use attributes inside a static method, those attributes must be static too. Now, inheritance. Inheritance means one class can extend another class and reuse or specialize its behavior. Extends creates an inheritance relationship. Dog extends animal, so dog inherits behavior from animal and can also add its own behavior, like for example, bark. Overriding means the child class changes the behavior of a method from the parent class. Use the override annotation so Java can catch mistakes. Now, interference versus abstract classes. This is one of the most common Java interview questions. An interface describes what a class can do. It's a construct. For example, the class payable must implement the pay method. An abstract class is a shared base class. It can contain fields, attributes, normal methods, and abstract methods that children classes must implement. Dog class extends animal class. It inherits shared code like sleep, but it must define its own make sound. This is the power of abstract classes. Here is the practical rule. Use an interface for a behavior construct, something the class can do. Use an abstract class when related classes share fields or common code. Finally, overloading versus overriding. The words are similar, but the meaning is different. Overloading means same method name, but different parameters. It usually happens inside the same class. Java chooses the method based on the arguments. Overriding needs inheritance. The child class provides a new version of a parent method with the same signature. This changes behavior at runtime. So, if we change the parameters, it's not overriding, it becomes overloading. The override annotation protects you because Java will show an error if you're not really overriding. Now, let's connect everything into a practical decision map that you can use while coding. Here's the OOP decision map. Need a new object type, class. Need control visibility, access modifier. Need starting values, constructor. Need parents behavior, extents and super. Need a capability, construct, interference. Need a shared base code, abstract class. Common beginner mistakes are making every field public, forgetting that constructors initialize objects, confusing this and super, using static for object-specific data, and thinking changed parameters are overriding. Quick quiz. Shared sleep and abstract make sound means abstract class. Same method name with different parameters means overloading. Child changes parent method means overriding. Many capabilities usually means interfaces. Final recap. Class is blueprint. Object is instance. Private protects data. Constructor initializes the object. This means current object. Super means parent. Static is class level. Interference is construct. Abstract class is shared base. Overloading is about parameters. Overriding is about behavior. In the next video, we'll move to Java core concepts and tools like enum, generics, exceptions, and exception handling, Maven, and JUnit testing.